Good day, class. We'll be looking at the electrolysis today. The meaning of electrolysis, the terms used in electrolysis, laws of electrolysis, and electrochemical series, proving of electrolysis formula, and then the videos of some Champ and White and NECO questions on electrolysis. Now, the meaning of electrolysis. Electrolysis is the process by which an electric current is used to drive a chemical reaction, often to split a molecule into its constituent elements or to deposit a melter onto an electrode. Or we can even say electrolysis is a chemical decomposition produced by passing an electric current through a liquid or solution containing ions. The major examples of what we are talking about is this electrolysis analysis. If you are to look at these two beakers that we have, we will discover that there are two poles inside, the one with zinc and the one of copper. In electrolysis, what we deal with is that we use an electrolyte to generate electricity through uh, water, or we say solvent. By the time the electrolyte dissolves inside the solvent, the ion is going to split. It's like when you put a salt, normal table salt, sodium chloride inside salt, inside water, you will discover that the sodium ion and the chlorine ion will separate. And this is done, if you want to know this, this is done through by using some chemicals and some machine in the laboratory. So we believe that when a particular molecule that is ionizable inside water are mixed with water or with solvents, they are going to separate into their um independent elements. That's why we say electrolysis is a chemical decomposition produced by passing an electric current through a liquid or solution contain ions. The ions are the element that split into the different uh, each type of element. So what are the terms that we use in electrolysis? We have anode, cathode, electrode, electrolyte, electrolytic cell, ion oxidation reduction, current density, electrochemical equivalent, and also we have Faraday's constant. When we are talking about anode, the positive charge electrode where oxidation occur, that is what we call anode. If you look at this electrolysis analysis two beakers that we have here, we discover that we have a zinc pole and we have a copper pole. The one that carry positive, any pole out of these two that carry positive is called anode pole. So one of it is anode and the one that carry positive is called anode. The typical examples of this thing is if you look at the accumulator, the car battery. Inside the car battery, there are two poles. They will write plus and minus on one of it will carry minus and the second one will carry plus. The one that carry plus, that lead pole that carry plus is called anode, and that is where the oxidation occur. Although oxidation occur on anode pole, while on cathode reduction occur on cathode. The next one is cathode, which is the negative charge electrode where reduction occur. The second pole that carry negative sign is called cathode, and if you check the car battery, you are going to have the two there, and that is where the reduction occurs. So you see, all this one is a CBT question. Reduction occur on which pole or on which electrode? Because the two anode and cathode are also called electrode poles. So oxidation occur on anode and on the reduction occur on cathode. Now let's look at the next one, which is electrode. A conductor through which electricity enters or leaves an electrolyte. This is what we call cathode. The two poles that we have just mentioned now, the anode and cathode, are the electrode. That is where the currents will enter and also leave. to generate electricity. The next one is electrolyte, a substance that conducts electricity when dissolved in a solvent or an acid or base. This is electrolyte. The chemical material that you dissolve into inside a solution, that solution can be water, it can be any solvent, which you dissolve your electrolyte. And the examples of electrolyte we can see a table salt, because a table salt dissolves in water, and when it dissolves or when you mix it with water, it generates ions, sodium ion and chlorine ion. Another examples of electrolyte is H2SO4, sulfuric acid, because it generates hydrogen ion and SO4, which is a sulfate ion in the water. Another one example of is C copper tetrasulfate 6 acid. It's also a CuSO4. It's also examples of electrolytes. So all these electrolytes, they are electrolyte because when they dissolve in water, they are very ionizable and also they generate electricity. So another example is of this is electrolytic cell, a device that contains the electrolyte and electrode of electrolysis. If you are talking about electrolysis cell, the container that holds the chemicals, all the connections together is called electrolytic cell. If you look at the car battery, you see that there's a particular solvent inside, and also you see the poles and other things. The container that holds everything is called electrolytic cell. The next term is ion. The ion, a charged atom or molecule that has gained or lost electron. If you look at the water inside the beakers on top of electrolysis analysis here, you discover that we have a zinc 2 plus ion, SO4 2 minus ion. So that zinc 2 plus, the 2 plus on top of ion is referred to this zinc rather, is called uh, ion. So when those electrolytes dissolve in water, they are going to be ionizable. Then we have oxidation, the loss of electron by an atom or molecule. That's what we call oxidation. While the reduction, the gaining of electrons by an atom or molecule. That is what referred to reduction. Then current density. The current per unit area of the electrode is referred to as current density. We have electrochemical equivalent, the mass of a substance deposited from an electrolyte by the passage of unit quantity of electricity is referred to electrochemical equivalent. That is the mass of a substance that move through the electrolyte at a constant unit is referred to electrochemical equivalent. Then we have a Faraday constant, which is accumulated to be 96,485 coulombs per mole, or we say approximately 96,500. So we have the laws of electrolysis. The first law states that the mass of a substance deposited from an electrolyte is proportionally to the quantity of electricity passing through the electrolyte in a given time. So this formula will be proven soon after this explanation. And the M in the formula stands for mass of a substance deposited. The Z there is stand for electrochemical equivalent of the substance, and the Q stand for the quantity of electricity passing through the electrolyte. What are the applications of first law used for electroplanting, electro refining, and electrochemical sensors? The second law of electricity states that when the same quantity of electricity current is passed through different electrolytes, the masses of the substances deposited are proportional to their respective chemical equivalents or chemical equivalent weight. And this is given as a mass of the substance 1 divided by the molar mass of substance 2 equals to the mole of substance 1 divided by the mole of substance 2. Now, the application of the second law, electrochemical series for electrochemical analysis, then electrochemical synthesis, battery and fuel cell. So these are their application. Then we have electrochemical series. If you want to calculate electrolysis questions, one of the major things that we need is electrochemical series, in which every student that want to solve electrochemical electrolysis questions need to know the position, the way they are arranged. There are many. Now, what do we call electrochemical series? Electrochemical series, also known as the electromotive force (EMF) series, is a list of a metal arranged in order of their standard electropotential. So this series is crucial in understanding the electrolysis. Now, I have generated a particular acronym that we can use to remember this electrolysis electrochemical series. The sentence that helps you to remember the electrochemical series in orderly manner is below. You can even if you can remember this sentence, it's very simple. Popular scientists can make a zoo in a low mood control more safely good. The P there stand for, if you can remember this sentence, popular scientists can make a zoo in a low mood control more safely good. Thus P there will stand for potassium, the S there will stand for sodium, the C there will stand for calcium, the M there will stand for magnesium, A there will stand for aluminium, the Z will stand for zinc, I will stand for iron, the L there will stand for lead, the H will stand for hydrogen, C will stand for copper, M will stand for mercury, S will stand for silver, and G will stand for gold. Now, note the letters above is not for the main symbol. It is just for the remembering of the series. So most important thing is their charges. So you must to know all these elements with the charges that they always have. Like potassium is in group 1, always carry +1, which is only plus will be there, and that means it's 1. So that charges is what you need most. So once you can list them in orderly manner like this, then you can say that in this series we have the numbers on top, like potassium carries +1, sodium carries +1, calcium carries +2, magnesium carries +2, aluminum carry +3, zinc +2, iron as well, it carry +2, zinc it carry +2, like that. So we must know them with their charges. So if once you can identify them like this, then you must know them their charges, because that charge is very important in calculating the electrochemical the electrolysis, especially in the first law. Now let's look at the proving of the first law of thermodynamics.
Good day, class. We'll be looking at the calculation under electrolysis today. The first thing is that we want to put a formula for the first law. From the first law, we know that uh, mass is directly proportional to Q, and we can call this one equation 1. So to break this proportion sign, we can introduce the constant by saying M is equal to ZQ. Just let them know that where Z is electrochemical constant.
Yeah, yeah.
Okay. So we now say Z is electrochemical constant. Then we can say M is equal to ZQ, and we name that equation to be equation 2. Now, don't forget that Q is the quantity of heat, which can later be formed to be IT. Current times time is the Q. So we can now substitute for Q in equation 2. So just say Q is equal to IT. The I stand for the current, the T stand for time. So you now say substitute for Q in equation 2. Then that will now be M is equal to Z. Instead of Q, we put IT. Now you call this one equation 3. Then Z is equal to the constant that we introduce. It has a particular formula to be relative atomic mass, RAM, relative atomic mass, divided by number of charges of the in the electrochemical series. This N stands for number of charges multiplied by the constant, which is Faraday, 96,500. So then we substitute this one into equation 3. This will now be M is equal to, instead of seed, we put relative atomic mass times time times current, which is I, times time, divided by N, which is number of charges, times Faraday's constant. So if you are asked to calculate anything under first law of electrolysis, this is the best formula that you can use to calculate. It's very simple when you input your value. So let's try to calculate those two examples under this first law. I'm going to solve one JAM question and one WAEC question. Number 1.
Yeah.
Now look at this question. This is one of the JAM question. A current of 5
Yeah.
So a current of 5 ampere is passed through a solution of copper 2 sulfate for 10 minutes. Calculate the mass of copper deposited. Now, what you need here is we want to look at what you want to calculate, the mass. Now you list what you are given out. Your mass is not given. You are looking for it. Then relative molecular mass of copper, RAM, it has been given out to be 63.5. Then the I is your current. Just say I is equal to 5. If you are dealing with rating, if it's CVT, just try to input the value and get your answer. T is given to be 10 minutes, but you have to convert that one to seconds. In electrolysis, always convert your time to seconds. It can be in days, it can be in hours. Make sure that you convert it to seconds. And if you want to do that, just say 60 times 10. So, and this will give you 600. Assume that our time is given in hours, then you need 60 times 60, and that hours we are given. But this one is in minutes, so that will be 60 times 10, and that will give you 600 seconds. Now, what you have to do now is that the number of charge N, if you look at the electrochemical series in the video that I've already explained, you will see that copper, it has 2 plugs. So the number of N here is 2, and F has given as a constant 96,500. Then you just go to the formula and imply all this, which is M is equal to RAM times T times I times T, divided by N times F. That will be 63.5 times 5 times 600, divided by 2 times 96,500 Faraday constant. And if you have to press your calculator, you are going to have 63.5 times 5 times 600, and that will give you about 190,500 divided by 2 times 96,500, and that will give you about 193,000. So if you have to divide your answer now, 190,500 divided by 193,000, and you have 0.98. Mass is always in gram, so as your SI unit. That's the answer for this. Now let's try the second law of electrolysis. This is the formula: number of mole of elements A divided by number of mole of element B equals to charge of ion of element B and charge of ion of element A. Now what happens in second law of electrolysis is that they always ask for the number of mole. They can also ask for the number of charge. You just make the subject of formula. Now if you look at this question, a quantity of electricity liberates 3.6 grams of silver from its salt. What mass of aluminium? You can see they are asking for the mass of aluminium here, not mole. Mass of aluminium will be liberated from its salt by the same quantity of electricity. Now if you have to look at this formula, the number of elements, number of mole of element A is not given, but we can use this mass of silver to get the mole of silver, because we know that number of mole is equal to gram, or we say reacting mass over molar mass. So this gram it has given to be a quantity of electricity of liberate 3.6 gram of silver. So this is for silver. You just say 3.6 is already in gram, divided by mass, molar mass of silver is given here to be 108. We just say divide by 108. So number of mole of silver Ag is equal to, just say 3.6 divided by 108. So you have it to be 0.03 mole. Then you go back to the formula. Number of mole of element A, we can call that one to be the one of silver. You already have it. Then you say number of mole of element A is 0.03. Number of mole of element B is not given, unknown. Let's use that. Then charge of element B, of ion of element B, which is aluminium. If you look at the electrochemical series, aluminium also donate 3 plugs, and that means it is 3. So that is why you have to know the electrochemical series very well. Then charge of, let me just use this, charge of elements A. Now silver is always +1. So you go to the formula now. What we are going to do now, we want to look for the mole of elements B. So when you get that, then you will be able to look for the mass of elements A and element B. Now let's imply them, plus this one into the formula. This will now be 0.03 divided by, we can call this one Al because we are looking for the one of aluminium. It's equal to charge of element B, which is 3, divided by element A, which is 1. When you cross multiply, you have this to be 3Al is equal to 0.03. So you divide both sides by 3 here. So Al is equal to, just say 0.03 divided by 3. You have this to be 0.01 mole. So to get what we are asking for, which is what is mass of aluminium. So far that you have the mass of aluminium, number of mole is equal to reacting mass. You can just put gram here over molar mass. Capital letter M. Let me use this over molar mass. Now what we are looking for is this G, the gram. So cross multiply. So now be G is equal to, which is mass, number of mole times molar mass. So this will be number of mole, we have already calculated it to be 0.01 times molar mass of aluminium is 27. I will give me that here. So if you are to multiply this, 0.01 multiplied by 27, then you should have about G, which is gram, 0.27 gram of aluminium. So this is the final answer.